Let's go ahead and get started. So, good morning, good afternoon, good evening. Hope everyone's doing well. It's a beautiful morning here in Dallas, Texas. About 14°C. Looks like a great day in Tel Aviv, which is where Sella is joining me from. About 18. Pretty day. So, thank you for joining us. We're going to talk about how to become API secure. So, the format that we're going to go through today is I'm going to talk about a few slides and a few concepts from yesterday, where we introduced the full API lifecycle that Wib has brought to market. Then I'm going to ask Sella, our head of innovation, to go through and give an overview of several of our offerings, of our product offerings. But fundamentally, while it's interesting to talk about our offerings, I really want to talk about the problems and the challenges that you're facing. So, folks in the meeting, like Santiago, Ove, I would love to make this an interactive session. So please hit us on the chat window and ask us your questions. I'll be polling you for questions as we go through the materials, because fundamentally this isn't about our products; it's about the problems and challenges that you're having. So I'll introduce the materials. Sella will take us through a few slides. We'll come back around. And we're really going to be talking about concepts that aren't new, but the application of these concepts with threat modeling and determining a behavioral baseline for API traffic. That space is pretty new. API security as a whole is pretty new, and as we've all seen, a lot of defenders are challenged to keep up. So the first principle to start with is that you can't defend an asset you can't see. I know there are a lot of security frameworks that we use around the world. I used ISO for years and years as a head of security for various divisions in the corporate for consumer. Over AIG, we used ISO. Here in the US, regulators use one called NIST. It's from the National Institute of Standards and Technology. It's a CSF cybersecurity framework. And the process that they walk you through in that framework I like a lot, which is identify, protect, detect, respond, recover. You can see that on the bottom of this first slide. Fundamentally, if you don't have your assets identified, if you have blind spots, you can't protect, detect, respond, or recover those assets or attacks against them. So Wib, our approach in bringing this this suite to market is we start with identification. We start with a really concerted effort to close blind spots from as many vantage points as possible in an organization. And it turns out that it really takes a comprehensive approach to do that, because you may have API calls in your code that are outbound that you may not see. You may have APIs that aren't going through your gateway. You may have deprecated and zombie APIs that are still running on old ports or things like that you don't know about. And these APIs may be surfacing vulnerabilities that you're unaware of until you actually hit them from the outside, ideally in production with something like our attack simulator. So it really is about how do you know, validating what you think you know, and then giving actionable results back to your security teams and your development teams so that you can remediate the issues, ideally in the code. So the way that we do that, the way that we do that is by shifting left with our code analysis tool all the way back into the code base. So we can see what's happening in your code and scan it and look for vulnerabilities such as BOLA, any of the API top 10 that we talked about yesterday, we've been talking about throughout this conference, and see the vulnerabilities actually in your code. We also do traffic inspection, monitoring traffic inbound and outbound, and that's really, really critical. So I know that a lot of companies are throwing words around like ML and AI and things like that. One of our co-founders, Dr. Tal Steinhertz, has a PhD in machine learning. He served as the CTO for the National Cybersecurity Directorate in Israel. He served with them for 27 years. And it turns out that API traffic is actually particularly well suited for machine learning. Normally, the traffic patterns are very predictable. So we can build a baseline of what normal looks like. And then the most important thing for a CISO or security officer is when something deviates from that norm, you get alerted. You need to know what normal looks like. And to do that, you need to be monitoring inbound and outbound traffic and building up those traffic patterns. So when you see surprise behavior or things that you weren't expecting to see, that's your best indicator that something is wrong. One key part about APIs that's different from typical web application vulnerabilities is the attack chains are different than what we're used to seeing. So if you're familiar with the old Lockheed Martin kill chain, API attacks work differently. They require attackers to chain things together differently. And so we get an early warning, and essentially our machine learning models can learn from what they're doing and turn the attacker into a pen tester. We can gain insight before they're actually able to exploit a vulnerability and potentially get data out to take over admin permissions, all kinds of nasty things that they can do if we detect that variance early. They have to kind of chain through the attacks, and Sella's going to talk about the attack simulator and how we replicate that in the wild to make our customers aware before the attackers do. And then fundamentally, you have to protect production. If you're surfacing APIs, and many companies, the stats I've been using are 30 to 40%. Several other presenters in this conference have said that their customers are seeing 50% undocumented, unknown APIs that their companies are surfacing to the outside world. Fundamentally, that's more of an attack surface that you have to gain understanding of, get your head around what the vulnerabilities actually are, and you can only really know what you're vulnerable to by simulating live attacks in test and in production. One of the challenges with APIs and Agile development in general is the old quarterly release cycle where you could have a manual penetration test run. Doesn't work in an Agile environment, and over 50% of companies are now, they say that they're Agile. I'm sure we could debate what Agile means to different companies, but the iterative release cycle of every 2 weeks, every 3 weeks, you can't add a 3-week manual penetration test at the end of every cycle. So getting the code analysis, the traffic inspection, and the attack simulation all automated and all running in real time is really critical to getting your head around your API security posture. And that's what we do. So you can see the way that these three products stack together. And then with the Compliance Defender is a piece that takes the intel from all three products and gives companies insight into what their compliance regulations and obligations are and whether they're meeting them. So whether it's PCI, HIPAA, GDPR, you name it, we can help with analysis of what traffic is actually going in and out via your APIs and give you that insight. One question that I got as a CISO all the time when we really started getting into the API security space several years ago when I was a CISO of a bank was, which of our APIs have compliance obligations? Which ones are handling credit card data? We are credit card issuers. You have to know where your PAN data is going back and forth. You have to know what data is going into Salesforce. You have to know what data is going to your online banking partners. And if you don't know exactly what traffic is coming across that APIs, it winds up being a blind spot, and it's pretty difficult to manage if you can't see what it is. So with that said, let me take a breath, get a drink of coffee, and I'm going to turn it over to Sella to walk us through the stack. Sella?
Sure. Thank you very much, Chuck. So guys, the first and most important thing is, as Chuck mentioned, we're talking about full lifecycle API security, because we want to make sure the organization itself is covered. We want to make sure the APIs are secure, and this necessitates both tech and processes in different parts of the lifecycle of APIs within the company. So we can divide it into the development, the testing, and production phases, and we take the data from all of these into one aggregated view of the Compliance Defender, but each part of the API lifecycle necessitates a different approach, different technology, and all three aspects together must be merged in order to make sure that the organization is covered in all parts. So we start with the development, because in the code is where the APIs are defined, and you have to have coverage of what's going on in your code to make sure you have visibility into all the endpoints in the code, and that all the endpoints that are defined in the code are secure from an API perspective. This is difficult because the security team does usually not control the development pipeline, and developers in today's modern Agile influenced cadence standard of development are developing APIs often more than twice a day, right? Deploying to production new APIs, and the security team needs to have some method of being on top of what is going on in the API development to make sure it's adhering to security standards. So our first product is the API code analysis, which is an engine that knows to analyze the source code of your organization and creates visibility into exactly all the endpoints that exists in the code base, and each endpoint, it makes sure it is up to API security standards, and most importantly, it finds all the API security vulnerabilities and issues that are introduced into the code. So upon each commit, the security team can be alerted and informed if there are new issues that need to be addressed. We recommend piping this into a CI/CD pipeline so that developers can get instant feedback each time they make a code, each time they deploy something as part of their code base. Using the code analysis, the security team can make sure that all the well-known vulnerabilities are scanned within the code base during each part of the development pipeline and gives them, no less importantly, visibility into all the API endpoints that exist. One problem we see with a lot of enterprises is that they assume that if they have an API gateway that enforces security policies, this means their APIs are secure. This is not the case for two reasons. The first reason is that the security team must have some visibility to make sure that all the endpoints deployed indeed are going through the API gateway. This is often not the case, especially in organizations that are microservices based. Because microservices allow developers to introduce additional endpoints, there's no guarantee that all these endpoints are going through the right API gateway. The question always remains, both now and in the future, is the security team sure that all traffic is flowing through the single API gateway they are aware of? Are there additional API gateways that are exposing additional endpoints? Are these endpoints enforcing authentication and authorization correctly? All of these questions can only be answered through the code. Because APIs are the #1 attack vector, it is very important for an enterprise to be able to have a tool that monitors the APIs and the API security as reflected in the code to make sure there are no shadow or zombie APIs lying around. So the first tool is the code analysis. See, we have a question from the audience. What type of analysis is made? Santiago asks, which type of analysis are made in the API code analysis, and to which extent, API level or also API implementation, and which would be the top 5 to 10 security vulnerabilities usually found? This is an excellent question.
Great questions.
In our code analysis, what we do is we go through the entire call stack of the code. So we map together who calls whom, functions and classes, and we create an abstract syntax tree representing the entire logical flow of the code base. Within this logical flow, we parse the code on a framework-dependent level. So every framework in every language has a specification for how to define an endpoint in it. Using this specification, our code analysis can learn exactly what routes are defined, what sort of authentication is implemented. Usually authentication is implemented both on authentication and authorization are implemented both on a per route basis and as part of an all-encompassing middleware. So our code analysis learns, or rather is configured, its algorithm knows how to deal with each framework individually and knows within each framework to create a list of all the routes that exist, and each route, what sort of authentication and authorization and what parameters does it receive and what sort of input validation does it run on each parameter. So using all of this information together, we can really build a mental or physical model of all the endpoints that exist, what do they receive, what do they verify, and create this visibility for the security team. This allows us to find many different types of vulnerabilities in the code, ranging from, we also scan the packages and we find outdated packages with any vulnerabilities, but most coolly, I would say, within the code itself, we are able to find routes that do not perform validation on input, routes that do not have proper authentication or authorization, routes that do not have rate limiting, and basically every one of the OWASP top 10 can be found in the code level as well. Imagine if you took your best developer and asked them to look through all the code and map a list of issues they find with you. This is what our code analysis tool knows how to do automatically for all frameworks and languages.
Yep.
The code analysis.
One thing I'd like to add to Santiago's question is what we're finding in engaging with our customers across industries is developers have gotten pretty good at authentication, but the authorization is where we're seeing a lot of problems. And so it's very common that we see in lots of environments is actually the API top 10 #1, which is broken object level authorization issues, BOLA. And it really requires not only an understanding of the code base, but also of the intent. What was the intent of the developer when they surface this business logic? Sometimes things are intentional, and we kind of need to, we need to understand that. And other times they aren't. So API hacks are a little different than, actually they're kind of a lot different than the traditional sort of SQL injection or cross-site scripting type of attacks. Those still happen for sure, no question. But if you look at the Facebook and Cambridge Analytica issue, that wasn't really a hack. Facebook surfaced an API that allowed them to download hundreds of millions of records, so they did. So it's not only defects, but it's also surfacing logic that you can apply a stimulus to and get an unexpected result because the developers didn't exhaustively test all the abuse cases. So you don't have to crack encryption keys or do anything super sophisticated if an API is written only to the happy path traffic and you don't test the abuse cases. So a part of what we do is we also surface scenarios and say, is this really what you meant? Is this what you meant to do? Because if it is, cool. If it's not, well, we got a problem, right? We either need to really rate limit or scope the authorizations properly so that you don't give away hundreds of millions of records to somebody that you wanted to provide 10. So turn it back over to Sella. Thanks.
Yeah, great point Chuck is making. I think from a developer perspective, it's easy to understand how authentication is much easier to enforce and validate than authorization, which is indeed what leads to BOLA being such a big problem. Authentication is easily enforced on an almost global level of, is this a user of the system, is usually the scope of the check, while authorization is a much deeper check, which is, can this particular user call this particular action and ask for this particular resource, which needs to be enforced on a per endpoint level because it reflects the business logic of who can see what within the system. So this is just from a developer perspective why authorization is so often gotten wrong on an API. This is a great segue to our tool number 2, the attack simulator. Now, our attack simulator is, in my view, a quantum leap in the world of cyber warfare because it highlights the fact that anyone with an access to an API, and the point of an API is for people to access it, so anyone with access to an API can try to attack the API, and a successful attack can mean direct access to the database or the private data of the company, and anyone with access to the API can launch a very wide range of attacks to see if they work against the API. You are within active contact with the targets, right? So this creates the opportunity for people to try advanced technology to try to force their way within the API or to find vulnerabilities, and this is exactly the kind of advanced technology that we're developing in our attack simulator. So our attack simulator is essentially an offensive weapon, or it is an engine with an offensive capability where you point it at an API and it launches all possible attack vectors against this particular API. So attacks customized for this particular API's logic and structure, and returns a list of issues and ways to hack this API. So if you feed a list of, say, the list of endpoints or a definition of a session of the API, and it fires all possible variants of ways to hack this API. It is like an army of 1,000 penetration testers running on at the speed of software. So we launch all these thousands of variants, and we get a list of vulnerabilities in the API. It is very close to an automatic vulnerability scanner at the API level that can run externally from an API from anywhere you can connect to this API. So the implications of this are that if a vulnerability exists in an API, pointing our attack simulator at it will very likely uncover these vulnerabilities. Since the vulnerability can be found and processed externally, this means attackers can do it the same way we do it. Our technology is probably a few years ahead of the market, and that benefits the organization that uses our tool to find its own vulnerabilities before the attackers do. But the organization that does not have the sense of mind to find, scan, and simulate an attack against themselves to find their own vulnerabilities will wake up when somebody else has run a similar attack simulator and found the vulnerabilities without sharing it with the customer. So the attack simulator is a tool that is best used at the testing phase of an organization and in production. In production, you absolutely have to run a simulation of an attack or wait for someone else to actually attack you, but you will be better off running such an attack simulation upon each change to your code. So before putting new code in production, you want to run a scan on the changes that are introduced and see if you introduced any vulnerabilities at the API level, which might give an attacker a highway into your database. So our first tool, the code analysis, helps analyze all the issues at development time within the code. Second tool, the attack simulator, is roughly a dynamic test of the API that helps uncover all the vulnerabilities at the API level as viewed externally. So code analysis, sort of white box testing, attack simulator, black box testing from outside. Our third tool.
One note on that, if I can, yeah. So as a former penetration tester and a CISO for 18 years, I totally geek out on the attack simulator because fundamentally, when we're talking to our customers, we can't have a one-size-fits-all approach, clearly. So, the needs of Santiago's organization are very likely going to be different from the needs of Ove or anyone else, any other company. As the CISO, I need to know first and foremost, what are my exposures to the outside world? I also need to know what's exposed via partner networks, and I need to know what's exposed to the inside. But fundamentally, there's 7 billion potential bad guys to the outside, and I really need to know what we're surfacing there. And so in many cases, the attack simulator is actually sort of the leading edge of us making, building a relationship with a new customer and helping to deliver value quickly, because they're surfacing APIs. They know some of the APIs that they have, but they don't necessarily know what those APIs are vulnerable to. And so what we've been able to do, actually not me, our product team, has been able to create this excellent win-win situation where Sella or anybody can help them through a proof of value, and either they get insight into vulnerabilities they didn't know they had, or you get a clean bill of health from a leading Israeli cybersecurity company that specializes in API security. So if you're the CISO and you're talking to your CEO or your board members, they read some magazine article about API security and they said, hey, should we be worried about this? The CISO can say, or your CEO or CIO can say, well, we looked into it. We found these issues. We got it back to the developers. We fixed it. We ran another scan. We validated the remediation. Or, yeah, we looked into it and we got a clean bill of health. Our API security posture is tight, and we're going to do another scan, in another quarter or whatever. Either way, it's a win-win to have an answer to that question. And so I'm, as a CISO and somebody that was, jokingly said for 18 years that CISO stands, CISO stands for career is suddenly over. It's always some blind spot that gets you, and this is the most effective tool that I've seen to close blind spots. So my product teams have to remind me over and over again, like, we sell stuff that's not just the attack simulator, right? So yeah, but that one as a pen tester and CISO is really near and dear to my heart. So anyway, sorry, I did put another poll question in the chat about confidence intervals that your security teams understand what your vulnerabilities may be exposed to the outside, same 0 to 100 scale. I have yet to find anybody that can truthfully and with a clear conscience say 100 that hasn't been working with us already because we showed them. So yeah, it's a great question for your head of development and your CISO as well. So turn it back over to Sella.
I want to add that similarly to Chuck, I too geek out over the attack simulator. My background is mostly in military cyber warfare, and my experience both there and at WIB, we have seen that it is very, very unlikely that a company with an API does not have API security vulnerabilities, and these vulnerabilities are usually of critical importance, of the type that's it's opening a door for attackers all over the world to try to walk into the organization. So any CISO that works at a company that has an API, a public-facing or partner-facing API, should be very worried whether this API was implemented perfectly, because if it was not implemented perfectly, then tools such as the attack simulator will automatically find the vulnerabilities within the API and will let an attacker have access to more data than you could probably foresee. So the number one vulnerability we often see, what we mentioned earlier, BOLA, broken object level authorization, means that a wrong authorization flag in the code, a wrong if, would allow an attacker to access other users' data, and couple that with a script, it would allow an attacker to access all users' data, which effectively means just downloading all the internal data from the organization through the API, which is a disaster. And so this is why we recommend running some internal scans, some internal simulation of an attack to find these holes in your API security yourself as fast as possible.
One thing on a side note, I got a question earlier this morning about have you made this free and open source to use? And it's something that we've contemplated, but honestly, as CTO, I'm struggling with the ethics of doing so, because so many companies are unprotected that I really don't want to unleash the API version of Shodan essentially equip attackers to do more damage than they're already doing when so many companies have this blind spot. So as much as I want to share and feed and nurture the open source community, this space is so immature and the gaps are so pervasive among militaries, government agencies, critical infrastructure, banking, finance, all of these industries. To Sella's point, we're pretty far ahead of the curve with the attack simulator. And I don't want to just hand out bazookas to everybody that can pick up a bazooka, because not everybody is equipped to deal with them yet. So coming back, I didn't answer that question earlier this morning. We ran out of time. But if anybody was on the earlier session that asked that, that's the answer. Is as much as we would love to support the open source community right now, we're really being careful about not releasing, API metasploit to the outside world to just, randomly do damage, because a lot of companies are frightfully exposed.
Absolutely. I think we're seeing within the cybersecurity world, and most pertinently within the relatively nascent API security field, an arms race between attackers and defenders, as is to be expected on such a playground. And it's important to partner with whoever you think can supply your side of the arms race to make sure that you're not behind technologically speaking. Arms races usually mean just a quantum leap forward once you develop some technology that the other side is not prepared for. It's very, very important to get there first. So we covered the code analysis, which deals with our development environment. We covered the attack simulator, which deals with the testing part of the life cycle of making sure your API is secure. Our third tool is actually our flagship product, the traffic inspection. This is the API defense. This is the API equivalent of a firewall. This is a tool that is installed at your API gateway level and analyzes all the incoming traffic, learns how it works, and learns how to flag attacks, learns how to detect things that are anomalies, as Chuck described earlier, learns when a request looks like someone who is not using the API the way it was meant to be used, but is using it in order to try to gain a foothold, to try to find a vulnerability, to try to hack the system and attack. So this system is a necessity for anyone operating an API who wants to stop attacks automatically instead of waiting to hear about them in the newspaper. And installing such a tool gives you a relatively very high level of defense for your API security, because it knows how to automatically detect incoming attacks and can integrate with your WAF or API gateway to block them. So traffic inspection is our production leg that we stand on to defend our system in production. Beyond analyzing and finding the vulnerabilities during development and testing, we want to make sure we're defended so we can sleep well at night. So these are our three tools. Chuck, do you want to say something?
Yeah, I did. So fundamentally, when we talk about the traffic inspection, there's an old practice in information security called threat modeling, and I'm old enough, so I got some gray in my beard. Back in about 2000, Microsoft released the Stride model. There are others like Dread and others, but essentially spoofing, tampering, repudiation, information disclosure, denial of service, escalation of privilege. And those are the things that you look for at any trust boundary. And you gather an inventory of assets, actors, interfaces, and actions, right? So who's doing what to what via what? Many companies do not have that insight into what's going on in their production API space, who's doing what to what via what. And the traffic inspection really is the backbone of how you get that knowledge and build your own threat model as to what normal behavior looks like in your space, what normal inbound, outbound, east, west, north, south traffic looks like in your API ecosystem. And then you build patterns and norms and behaviors, and you can train the machine learning algorithms to really, when something looks unusual, like if you have the traffic inspection running and we hit it with the attack simulator, it lights up like elephants coming down Main Street, right? That's all kinds of unusual behavior that you wouldn't expect to see. And that is the best indicator that something is wrong, whenever something is unusual, deviates from the norm. So it stands out like a black dot on a white background. Having this in place really gives you that understanding of what normal looks like in your shop. And even if an attack vector is novel, it could be the next log4j or what, it doesn't really matter. It was an unusual request, an unusual post, an unusual get, something that you hadn't seen before, and you get alerted that something is wrong. And that's really, really critical to being able to mount an effective response is what normal looks like. Without something like the traffic inspection running, you simply don't. It's based on assumption. Here's what's supposed to happen, but that's not necessarily what's actually happening. And that's a big blind spot for a lot of security operations teams. Before joining WIB, I built with a really awesome team out of Dallas, a digital bank. And we stitched together 400 APIs to stand up that bank. And getting the visibility that we needed to really determine what normal looks like was core to the information security program. We were lucky in that we were all digital. Almost all companies today have some mixture of legacy and brand new, and it's very difficult to get that kind of little insight. So yeah, don't want to belabor the point here, but finding out what normal looks like in your day-to-day and then alerting on variances is absolutely critical.
So to recap the various products we've seen, each one constitutes a part of a whole approach, a holistic approach of covering the full life cycle of the API. So you absolutely need a tool to cover your development, you need a tool to cover your testing, you need a tool for your production defense. All three tools together can give your organization 360-degree coverage of your API security, and without even one of them, you don't know what you're missing. You don't know if you've missed something in the code that is deployed outside of your zone of comfort, outside the API gateways you're aware of as a security team, if you don't have a development approach towards code analysis. If you're not testing, running a simulation of an attack, you're just waiting for somebody else to come with an equivalent tool to automatically scan and find vulnerabilities you were not aware of. And if you're not defending in production, then you don't even have a closed door or any type of defense against API level attacks, which can't be blocked by existing technology because they rely on logic-based mistakes in the code rather than a signature rule-based fields in the HTTP request that can be blocked by other technology. So you need all three parts, and then you want to have one view that aggregates all the data to make sure the security and compliance and regulation and legal team can stay on top of everything to make sure that their APIs are properly documented, visible, audited, tested, and defended.
So we have some new folks that joined the meeting just in the last several minutes. So Paul, Anders, Timo, welcome. We put some poll questions in the chat because as fun as it is for us to talk about our product suite, and we live and breathe this stuff every day, and we think it's pretty awesome. I'd really like to gain some insight into the problems and challenges that your teams are facing. So please feel free to either answer the polls in the chat or post your own questions in the chat so that Sella and I can respond. I would love to get some participation rather than just sort of speaking at you. So Santiago, thank you very much for your prior questions. And just a quick time check, we have about 7 minutes left. So Sella, do you want to talk about the different ways that we can actually gain access and insight into the traffic via the traffic inspector?
Sure. So the traffic inspection is installing a defensive piece of software, sort of like an API firewall within your system. So the more technical-minded among us might wonder, what is the architecture of such a deployment, and how does it work with the existing traffic flow that an organization usually has? Usually, most security-minded organizations already pipe all of their traffic through one or more API gateways, so they can consolidate things like security measures at the API gateway level. So our traffic inspection is very flexible, and we support installation on-premise, on your private cloud, in a hybrid installation, or in our private cloud to make sure that everything can work. We usually recommend a traffic mirroring solution, but we also support installations such as Sidecar and reverse proxy via plugins with all common API gateway reverse proxies. So we've worked very hard to make sure the traffic inspection is as flexible as possible because it is, as we mentioned, the flagship paramount piece of an API defense in production. I would also, I just want to add for people who are new to the field of API security to understand the size of the issue that is at hand. Because APIs are quickly becoming the de facto way that all enterprises and servers expose themselves both to partners, other servers, and endpoint clients. And so the issue of making sure the APIs are secure is a wide, all-encompassing effort that might remind us of about 10 or 20 years ago when we started moving to the cloud. So the same way cloud security needs many different parts to make sure the organization is covered, similarly, API security requires a full lifecycle approach that requires, as we mentioned, a development component, a testing component, and a production component, each of which act separately, but all of which need to act in unison in order to grant the organization full coverage. I do recommend you guys check out Chuck's previous talks and my own previous talks. You can find them both on our site at wib.com and at Apidays. So you can further your understanding and education of the API security landscape, how it's changing, and most importantly, how it affects you and your organization.
Absolutely agree. So Sella, I was just corrected. We have a few more minutes than I thought, which is great. So the folks in the audience, not to put anybody on the spot here, but we would love to get your questions. So we are available to request a proof of value from us today. Find your blind spots, find your vulnerabilities. Earlier mentioned about the attack simulator. where give us a couple of APIs that you want us to scan, either in a lower environment or in production. Kind of the I don't always test, but when I do, I test in production. But it really is critical to understand what's actually running and exposed to the outside, so that that you and your companies can get and stay ahead of the curve. So our contact info is right there, info@wib.com. More than happy to start and sort of meet you wherever you are in your API security journey. So if you're just coming into the space, don't feel bad. 62% of companies in the recent survey have no API security program in place, and unfortunately, it's the #1 attack vector today. So 2019, Gartner called it and said by 2022, API security or APIs are going to be the #1 vector for attacks. Then in 2021, they revised their guidance and said, yeah, we kind of undershot that. It's already #1. So it's a big challenge, and it's something that we're here to help with. So any other questions from the audience?
In the meantime, I will add, Chuck, that it's very, when we do show a proof of value to companies, when we work with companies and start them on their API security journey, it's usually very eye-opening for the company that we show them just how insecure they are. Usually as part of our proof of value, we show them, we find together the vulnerabilities in their APIs. We show them the amount of damage an attacker is able to perform on them immediately. We essentially show them their own zero-day vulnerabilities in their own APIs and just what an attacker can do. Usually this amounts to pulling out the private information of other clients, or executing code on their servers, or performing a denial of service attack, which can bring down their service. So the implications are really pretty potentially hazardous. And once we work with a client, with perhaps one of you folks in the audience, and work with you and address your API security issues, after we show you the vulnerabilities that you personally are exposed to, this really may help you understand the importance of quickly addressing your API security issues, because there's a very good chance you're very exposed right now. And we have the tools and the experience to show you this very quickly. So we recommend getting checked as soon as possible, as they say.
So one thing to mention, especially for folks in heavily regulated environments, we frequently recommend that your assessments run through your legal counsel, either internal or external counsel. If you have a cybersecurity counsel or an incident response program with the external counsel already, and that way we provide the results back to them, and you can protect the results under attorney-client privilege. So when we do find something exposed to the outside, and if it's a compliance issue, obviously companies have to act, and they want to be responsible in the way that they treat that information, right? So typically we work with CIOs or CISOs, especially in regulated spaces, in companies subject to GDPR, HIPAA, anybody in the military complex, financial services, banking in the U.S. and other places. We often suggest or recommend that let's go through legal counsel so that you can protect the results, because it can be pretty startling to see what we can find. So we don't want to just send that back via email, right? Here you go. Here's a whole bunch of sensitive information you were exposing to the outside world that you didn't know about. So great point, Sella. Thank you. All right, folks in the chat, I don't see any other questions coming in. Let's give it another 5 seconds, and then we will wrap. Thank you very much for your time and attention this morning. And if you have any questions, you know how to reach us. Hi, awesome. You're welcome, Santiago. Thanks for joining. Really appreciate it. Thank you for your participation.
Thank you very much, everyone. Please be in touch with us.
All right. Y'all have a great day. Thank you very much.
Take care, guys. Stay API secure.